On the bench today, we do not have a CB radio. We have a piece of CB radio test equipment. So today we have a B&K Precision Model 2040 CB signal generator. Now this thing, boy, has it ever had a trip. For starters, you're going to notice there's a little red box over here. Well, I need that little red box to make this thing work, because this does not operate off of 120. It operates off of 220, 240. And I'm not talking two-phase, like in the United States, like your dryer or your oven. I mean 220 on just a single, this now belongs to Peter in Australia. He got this from somebody in Germany. I think he said was in the army. I'm not sure. Got it from that guy, had it sent to the United States to somebody here, basically just to then have it shipped to me. Once it calibrated, he is physically, I'm going to assume probably tomorrow, he's probably going to pick this up because he's got some other stuff he's picking up. And then it's going, I guess, on a sea container and going to Australia. So yeah, this thing originally went from, I guess, the United States to Germany. Lord knows if it did much moving around in Germany. Then back to the United States, and now it's going to, like I say, to Australia. So yeah, that's what I have to run it off of that, because I need to be running it off of 220. So that is a automatic electronic voltage regulator. You can, if you were overseas, you could take that, plug that into a 220 outlet, and it'll output 110 on these two jacks, and then 220 on those two. Or if you're in like this country, I plug that into 120 volts, and then I get or 110. I get 110 out of these two, and 220 out of those two jacks. So, and this has the plug on it that has those funky round pins. So I've got an adapter that goes from them to the standard dual blade, like 120 volt outlets like we use in this country. But it's in really nice shape. Did have, I guess you could call it, some shipping damage, which I'll need to take care of. But luckily nothing bad. Just something popped loose on the inside. These things are built like a tank. It's just, oh my God, if you ever have to work on one of them, honestly, I think a lot of people they'll find another one, depending where the fault is in these. The main RF deck in these things, it's not pleasant to work on. And you can ask Buddy at the radio shop about that. I think he's had one he's been tinkering around with for like a year, trying to get it working properly. This one, luckily, does seem to be working just fine. That does need calibrated. Actually, the frequency looks like it's stabilized now. I've had this thing plugged in for about a half hour. It does have a ovenized oscillator. So one thing to remember with these is anytime these are plugged in, doesn't matter if you have the power switch turned off, anytime this is plugged in, there's a little ovenized box, there's a little styrofoam box in the RF deck on these things, basically just a resistor, but heats that box up. That's on 24 hours a day. So anytime this thing's plugged into a wall, irrelevant of the power switch position, that little ovenized box is on. Idea being, the instant you turn this thing on, your frequency is stable. You don't have to wait 15 minutes, a half hour, an hour for this thing to finally stabilize in frequency before you can use it. The oven's always on, like most test equipment actually. Most all my signal generators and communications test sets are like that. Even when they're turned off, the either TCXOs or OCXO modules and all of those, they're on all the time. So this one was off by, I think it was like 400 and some hertz, the carrier. And you can see you look at the spectrum analyzer back there, you can see it jitters back and forth once in a while. That's just the nature of the beast. Older style signal generator like this, PLL synthesized style signal generator, they have a little bit of jitter to them, so that's just common. You're going to see that. But otherwise, yeah, they're very stable. Amplitudes looks good on this one. Actually, the amplitude was like dead nuts on. I had, now I can't measure the amplitude at the moment because currently I have the output going to a splitter combiner so I can hook it up to 2 instruments. So I've got one line going to the counter, the other line goes down to the spectrum analyzer. But when I had this run straight into the spectrum analyzer, yeah, you put this, like I have it right there on 0 dBm on this bottom scale, it was dead nuts on 0 dBm within in like 0.1 to 0.0 something, you know, dBm of being accurate. So, you know, you could make up for that with, I mean, it's an analog needle, so that's in the eye of the beholder, I guess you could say. So yeah, I'm going to say the amplitude's dead nuts on. Frequency, like I say, it was off. I had let it warm up for like 20 minutes or so, pulled the cork out, I'll show you in a minute, of the little box, and adjusted that, and it looks like it's stayed pretty much stable right around there. So you can see it's bouncing around 4999 to 5000. So yeah, it's pretty much, the oven has warmed that box up to a stable temperature, so the crystals stabilize now. It did come with the original manual. Didn't come with the service manual, but I have an original service manual. Of course, unlike a lot of stuff, you know, nowadays, you know, back then when you used to buy something, you used to get schematics with it. So yeah, it has the original schematic, the original warranty card, and yeah, this is the operations owner's manual. But one thing, and I thought every single original piece of paper that was ever printed for not only these but also the 1040 CB Service Masters. Well, apparently I didn't, so I need to photocopy this. This, I guess, is an original little sales flyer for the 2040 and the 1040. Now, I have these, but the ones that I have are written in English. That ain't English. I do read German. That's one, I do know a second language, German, but yeah, it's in German. It did come from Germany, remember? So, yeah, I guess they marketed these things in Germany back in the day. So there's the original sales brochures for the 2040 and the original sales brochure for the 1040 written in German. So that's just kind of interesting. So, yeah, like I said, I'm going to photocopy that just so I have it, because I've never seen one of those. So let's take a look-see at the inside of this. The damage I'm speaking about is, you can see this box is kind of cocked sideways. Yeah, it's just kind of bouncing around in here. Kind of poor design. I mean, these things are built like a tank, but if there was one downfall to, well, 2 downfalls, working on them for starters, which I'll get into in a minute. But as far as mechanical goes, very good units. Really nice heavy-duty attenuator assembly. You can see it's kind of like a camshaft, has lobes on it. I'll never get it in the camera view because they're direct underneath of those lobes. There's little plungers that stick out underneath each one of these wheels, and that's a switch that goes down and either turns on or disables the basically a resistor down in there, and that's what they're using to set the output on this in steps, is that attenuator block right there. This box, the only thing that holds this to the bottom plate on this is 2 screws, and one of them is MIA. It looked like it ripped out. It literally got pulled out to look in the box, see if it's actually still in the box. But yeah, so this thing was bouncing around in here, so yeah, it's not good. Luckily, nothing got damaged, so it works fine. Now these have very good shielding. It has an internal shield, okay, that covers this internal metal box. Then there's a piece of foam that goes in on top of that for some more insulation. And then there's the top metal shield that screws down. The problem is, this box only has those 2 little screws holding it, and being shipped overseas and back and, you know, across the ocean again, and now it's going to go across the ocean yet again because it has to go to Australia. Yeah, if you ever want to ship one of these things, do yourself a favor. This topmost plate that screws down, get some kind of foam. Can be spongy foam like this or something a little bit more dense, but glue some foam to this top plate here, you know, cut out. Don't make a little tiny piece, but it's, you know, something, a chunk to fit in the middle, but height-wise, so that when you have this cover installed, that foam actually comes up. It's going to need to be fairly thick, you know. It's got to go from here the whole way up to here, you know, this lip right here. But what you want is you want that foam to come in contact with the top cover. When you put that top cover down, it should just slightly compress that foam. That'll push down on this thing to prevent it from ever moving around. That way it helps to take some of the stress off of those two poor little screws in the bottom. Now, working on these things, yeah, good luck. That's where I say you can talk to Buddy about that. He'll tell you the joys of having to work on one of these. I have several of these. I have several that work. You know, there's one right there on my bench. And I have a couple spares that work. And then I have some broken ones. And I ain't even going to attempt to fix them. Not until basically my last spare with it would ever stop working. I've never had any problem with the one that I use here. I have, I think, what, 2 working spares. You know, so if I have one that breaks, you know, like if this one here ever breaks, it'll just, you know, that one would just go out on the shelf. I'd dig out my other spare. If that second spare would ever break, yeah, then I'd have to start fixing them. But just because they're such a pain in the butt to work on, this module, you have to pull this little foam block out here, and then the board kind of pivots up. But to actually get this board out, yeah, you have to desolder every connection along the front. Now you can fold it up. You desolder the braid there, and you can get this thing, the board kind of tilted up. But yeah, if you ever actually have to remove that board from the shielding box here, you're going to have to remove. See all those pass-throughs right there? Well, those pass-throughs from this box go to, you know, you're either going to have to remove the wires, you know, every wire where they come up to all those little feed-through capacitors. Yeah, it just, and then from there, this inner box has a little interfacing between here and the pass-through capacitors here. There's actually either a resistor or inductor, depending on, you know, what's on the line to go between these two. So, yeah, it wasn't meant to be worked on. Now, luckily, I need to ask Peter, actually, if he wants the electrolytic capacitors replaced in this. You'll notice there's no aluminum electrolytic capacitors on this board. None. It's empty. There's tantalum capacitors. Lots and lots of blue-dip tantalum capacitors. That's great. I don't have to change them. They were properly rated and valued. I mean, yeah, they can go bad. They're the older ones, but yeah, I've never had one go bad on one of these boards, so yeah, we'll have to worry about them. The only electrolytic capacitors in this, they're a little bit challenging to get to, but this front, I think they call this the audio board, but actually it does a lot more than that. Controls all of the metering functions, basically everything. It, you know, runs through this board except for the actual frequency that just goes straight out to the jacks on the front. But the large majority of your calibration points are on this board. You can see there's a whole row of trimmer resistors here, and there's actually even more down in that you have to get down into to adjust. But this is also the power supply board. You have your step-down transformer there. That comes over to this board, and then there's 4 large axial lead aluminum electrolytic capacitors. You can actually just see one right there underneath of this trimmer resistor. You can see one of them, but there's 2 on the top, and then there's 2 down farther on the board. So yeah, you got to get this thing leveraged out of here, get this board out to even replace those 2 caps. But that's pretty much it, though. That's, yeah, there's, yeah, luckily, like I say, none to change on that. Like I say, this one seems to work okay. The controls were horribly dirty before. Man, when I first turned this thing on, I'd hit the amplitude and it would just sit there and bounce up and down in amplitude, and you jiggle it back and forth, and it would finally stabilize. So I gave that a shot of cleaner. I can't get to the bottom controls here yet because I need to pull that board out, but I could get in and clean the modulation amplitude, because that was another thing that was just horribly distorted. Turn on some modulation, you can see it there. You know, I can turn it up and turn it down. Before, it was just, man, it would just go batshit crazy. That's another way to put it. It was just, yeah, it was just horribly, because it was so, the control was just oxidized. Now this is one thing I do need to take care of, but that should be fine. I'd be able to get this in the alignment. You can see when I'm on 400 hertz modulation, it does go full scale to 100%, but when I go to 1000 or 2500, and that's at maximum rotation. I can't get up to 100. So, but it actually, if I look over there at the spectrum analyzer, yeah, actually the amplitude is off. The amplitude's just, so actually the meter's right. It looks like. I can see that it goes up when I switch to 400. So, but like I say, that should be able to be taken care of in the alignment. And sitting here talking, looks like it's still maybe going up a little bit. Yeah, it's still going between 4999, yeah, 5001. So I'd say these things are probably accurate as far as once the frequency stabilizes. They have maybe like a 1 or 2 hertz jitter, because like I say, you'll see the counter goes 4999, 5001. So yeah, it probably has like a 1 to 2 hertz worth of, you know, variation in frequency. And if you zoom in, if you set the span on the spectrum analyzer down to like, you know, 500 hertz or something, you can actually see the carrier moving around. And occasionally you'll see it jump a little bit, and that's it trying to stay locked. Actually, you can see it now. It was just kind of wobble wobble, and then it'll stabilize. But the nature of the beast. You know, if you watch oscillators and CB radios, you'll see them do the same thing. And they're basically kind of, that's what this is if you think about it. It's basically a radio that doesn't receive. This is basically a transmitter. It's a 50-channel transmitter with a calibrated output, and, you know, 3 different frequencies that can be used for modulation. But yep, looks like it's in really nice shape. So let me get to it. I need to get that box reattached. You know, the RF deck there, I need to get that reattached to the bottom plate. Get the calibration done on this thing. Get a hold of Peter and see if he wants me to change those capacitors in here while I'm into this thing working on it, and get it boxed up, and then he can pick it up. I guess I think he's stopping by tomorrow. I mean, he's going all over the U.S. He's got, I think, a couple thousand CB radios he's purchased here in the United States. He's got a car. He's picking up, and that's actually nearby here, he's picking up a Dodge Charger. Then he's got to go, I think, to New Jersey to pick up like a Lenco transmission and a bell housing for a drag car for a friend of his in Australia. Yeah, he's just picking up, you know, hey, if you're coming to the U.S., you might as well do it all in one fell swoop. Get everything you ever wanted. So yeah, apparently he's bought out a couple huge collections of CB radios. You know, several hundreds. I think that one guy had over 1,000 radios, I think. So yeah, he's filling up a sea container full of radios and importing them into Australia. And good luck there. I don't know how they are with the electronics down there with transmitters. I hope everything goes smoothly getting that imported. But so let me get to it. When I get done, I'll show you what I mean by the foam I'll stick in this thing. Like I say, you just should stick something in there. Now, if you have it and it's never going to leave your bench, you know, even if you move it around, it'll be fine. But if you're ever going to ship one of these, that's where you should really put some foam blocking. Even if you don't make it permanent, just put something in here in between that RF deck can and the top cover. That way it can't, you know, a dropper, if the box gets turned upside down and it gets dropped, that module doesn't rip loose. It'll have some, you know, rigidity between the top of that cover and this top cover here. Have something to kind of hold it in there. So let me get to it and we'll get this thing aligned. Okay, so I got her all finished up now. Got her calibrated. So actually, let's see here. For starters, the inaccuracy in the levels for the 400, 1000, and 2500 hertz modulation. If you look at the meter now, you can see we're at 100%. So it's adjustable from 0 to 100% on each of the different modulations now. Put it in CW. Slide the switch over to the delta frequency, and then with the delta frequency adjustment. So this is in case you're not familiar with these signal generators, when you pull this knob out, there's a couple knobs on these that have multi-function. This one you pull on and off, this one you pull on and off, and this one you can pull on and off. When you pull this one out, it allows you to adjust the delta frequency. You pull this one on, that turns on a 455 kilohertz signal generator that is then the amplitude is then adjustable with this rotary control. And when you pull this knob on, it's one of the things that makes this really, really, really handy piece of equipment. If you do alignments on CB radios, they always tell you, for, well, as long as the radio has a noise blanker circuit, you know, a switch, and you need to do an adjustment to that. You need to adjust for your, they'll tell you at some point in the radio, it'll usually be a diode or a transistor. There'll be a test point you attach your oscilloscope to, and it'll tell you to inject a pulse. Most people don't have signal generator. You know, if you're using old school equipment, you may not have a signal generator that can produce the pulse that service manuals will tell you to use. You don't have to worry about that with one of these. You just pull this knob out. It's a broadband noise generator, and what you'll hear in your speaker on your radio is just static. It sounds exactly like an old straight wire spark plugs in an old car. It's exactly what it sounds like. Horrible ignition noise is the noise you get when you pull this knob out. But that's the pulses. And it varies a little bit, because like I say, it's a broadband noise. But what you'll see when you're adjusting inside the radio is you'll see, and you'll adjust for peak pulses. Just follow, and that varies from radio to radio, but just follow the, you know, the alignment procedure. But this has that built into it. The delta control, what that does is, so this is a multifunction switch here which controls what this meter reads. When it's in the left position, it's the modulation meter. When you flip it over to the right position, it's the delta frequency. It has a little delta logo there and the delta frequency. And then you pull out this control, and this allows you to then vary the frequency that's coming out of this. So if we have it in CW and you look over there at the spectrum analyzer, you'll see as I turn this knob, I can turn the frequency back and forth across the screen. Okay, because I'm actually moving the carrier frequency. When I push it in, it's locked on whatever channel you have it set to. So in this case, channel 1, 26965. You look up at the frequency counter there, you can see 26965. But when I pull this out, it allows me to adjust it, and you can use that then for sideband. So you would have a carrier. If you wanted like 1.5, you know, your standard sideband offsets in radios are usually either 1.5 or 2.5 kilohertz. So you could set this to touchy here. You can see there's, you look up the frequency counter up there, you'll see 269,665. So that's 26965 plus 1.5 kilohertz. But that's now adjusted properly, so which that was actually rather far off before. So you can see I've got 26970, and you can see we have it down here in the bottom scale. It's on the 5 kilohertz, so that's 26.965, the channel we're on, plus a positive, that's what the LED indicates, 5 kilohertz. So 26965 plus the delta frequency. So actually, 96, get back up there, it should be 970. Yeah, 965 plus 5 is 970. And then same thing if you go in the opposite direction. So if you go negative, you watch the carrier over there on the spectrum analyzer, you can see as I continue to turn to the left, we're now in the negative. So anything that's displayed on this meter will be minus the frequency we're on. So we're on channel 1, again, 26965. If I go out here to the 5 kilohertz, there's 269,600. At one, like I say, very touchy. You've got over 10 kilohertz of range on a single, you know, a single control here, and actually it will exceed 5 kilohertz. Because you can see if I turn this knob full clockwise, it actually goes to 2697009 or 099. If I go full counterclockwise, I can get to 2695691. So it actually has over 10 kilohertz of range. And get right back to hold my tongue just right, turning the knob. Oh, just went just a little bit past. Which you don't need to be that accurate for when you're using that control anyhow. You can see. So that's pretty much it. Like I say, it's a good working unit. The output, I did did calibrate it. It was very accurate, but it was off just a hair, so that has been calibrated. It was within probably 0.05 dBm. You know, like I say, the accuracy was surprisingly well. The frequencies were off, the modulation was way off. Actually, the modulation frequencies were all off as well. 1000 hertz was probably the one that was closest. The modulation percentage was the farthest off on the 2500 hertz, but all of those have been set properly now. So, good working unit now. So, ready to service CB radios for another 30 or 40 years, hopefully. And pray to God nothing ever goes bad inside of this box, which is the last thing I need to do is attach this box, because it's still, as you can see, wobbling around in there. Just one screw barely hanging on by a thread still. So let me get this thrown back together, and I can have this ready for Peter when he comes to pick this up, either tomorrow or whenever he gets here. Like I say, he's up the road in Harrisburg right now at a hotel. He flew into Harrisburg, I think, late last night. Came in from, God, where was he? California, I think. He's been all over the globe. I bet that guy is just a walk-in case of jet lag. So, any case, there you go. There's the... If you've never seen the inside of a BK 2040, there you go.